Kind of a continuation of the tailstock alignment video, and also in part the lathe leveling video. But what I'm going to do is go into how to run a lathe, and I'm going to do the twin collar test, which basically is almost like the other video I have on tailstock alignment, making the test bar, but instead of having just the bar that we machined an end on, what this is going to have is it's going to have two collars on either end. It's going to have one collar here and one collar here. This is also 12 inches, just like my other bar. But what you're going to do is we're going to Loctite a collar here and here, and then set it up on centers in the lathe. And with a nice sharp round nose tool bit, we're going to skim across this collar and skim across this collar, and we're going to take our micrometer and we're going to measure it and see if we have a difference. So what I want to do is I want to test this method against the other one that I had for aligning the tailstock and see if there's actually any difference between them. So after leveling the bed, what I'm going, which has already been done in another video, and I actually did yesterday, what I'm going to do is I'm going to put the test bar that I originally made, which is hang on a second, let me show you just what I mean, which is this one here with the machine face, the exact same one I used in my tailstock alignment video. I'm going to put this back in the lathe and just double check my tailstock alignment, make sure according to this bar that I'm right on center. Then I'm going to take this bar and put that in the lathe and do the skim cut, and we'll see if there's any difference. So right now what I'm planning on doing is I already have this billet faced and center drilled. What I'm going to do is I'm going to step drill it. What I have is just a 1/4 inch drill bit in here now. I'm going to go from 1/4 inch, I believe this is 7/16, yeah, 7/16, and this is a 5/8 reduced shank drill. And then I actually happen to have in my collection of reamers, if you can see that, 0.7467 diameter. So it's a few under the 750. So the you don't necessarily need one of these. I just happen to have this in my toolbox. If you don't have a reamer, you can either bore it to the 3/4 inch diameter or slightly under the 3/4 inch diameter for a press fit, or you can still use a drill and just press fit it. But let me go ahead and start drilling this. Like I said, I'm going to drill this here, and then I'm going to take it over to the bandsaw and I'm going to split it down the middle, or that's the plan. See how that works out. Now we're getting ready to use our silver and Deming bit to get us up to 5/8 to be able to be ready for the reamer. Just a quick word on the silver and Deming, the reduced shank bits. Might be a little hard to see, but you see this flat here? There's 3 of them spaced around here like a triangle, just like the jaws of your chuck. So what you want to, your Jacob's chuck. So what you want to make sure is that each jaw of your chuck grabs that flat. So when you put it in, just make sure you're on right. A little twist. And also, after you put it in on your chuck here, because you're going to have a lot of rotational torque on this, when you tighten down your key, do more than one hole. I know it sounds stupid, but you'll actually be able to get another little turn out of the end. That'll make sure you're nice and solid. You want to turn these low, you want to turn these relatively slow speed. I have this set in back gear right now at my highest gear in back gear. We'll tighten this down and use a lot of fluid and just slow feed. And also, these drills aren't something that you're gonna want to use as your only drill in your hole. You want to pilot drill it, step drill it, keep going diameter by diameter. You don't want to just try to plow through a piece with one of these, because you'll either kill the bit or your hole will just be way off center. That funny noise that you're hearing is the load on my back gear. If you don't have that spring tension adjusted enough, you'll pop out of back gear every time you put a load like this on it. There we go, we're through. Alright, let me set up for reaming. I'll show you a quick video on how we do that. Okay, change of plans. I can't for the life of me find my 5/8 Jacobs chuck, so we're gonna bore this out. I just have a little boring bar that I made out of a small 1/4-inch bit in my block, just because my round boring bars, I can probably fit my smallest one in there. It's gonna be tight. This is going to flex a lot. It's actually going to flex a whole lot. But if I go slow and take light cuts, I'll be able to whittle it down. Let me get myself out of back gear and back into normal. Touch off. Alrighty, I'll just go at this. I'm assuming you don't want to see the whole thing, and once we're done with it, I got my hole bored all nice for a nice tight fit on the that 3/4-inch bar. Surface finishes okay, but it doesn't really make that much of a difference. And we're going to cut it on the bandsaw. Now, this is one of the reasons why this bandsaw is kind of a pain in the ass sometimes. If you can see where this blade is compared to where these vice jaws are, and you get a decent gap there. And it's actually, let's see how much it actually is. It's actually, you're looking at a gap of about 3/4 of an inch between, as far as this stationary jaw will come out in the blade. This one I can move a little bit here, but this casting here, depending on the size of the piece, will hit this guard. I can move this back a little bit further, but then you're further away from where your part is, you have more of a chance for that blade to flex. Now this piece is slightly too short to fit where I want it. There's halfway and I'm missing the chuck completely. So we're going to cheat. Well, what I'm going to do eventually is actually get a new piece of angle iron here and here and remake these, but for the time being we're going to cheat. So what we're going to do, open this out a little bit more. Get another chunk of metal the same size as the one that I'm using, stick it in between the jaws with a couple of pieces of waste stock here, but right up against the blade. Now I should be able to lift this. Sorry about hitting the camera. Get that where I want it. We'll call that halfway. And tighten everything down. It's not going anywhere. Pretty even. Let her go. Okay, got our two collars cut, and we faced them off both sides. Made sure they were nice and even. They might be slightly different sizes. Actually, we'll find out right now how close we are. $628 thousandths. 620 thousandths. Wow. Pretty damn close. I like that. And we're going to go about 2 inches on our bar from the end here. I'm going to put the outside edge right up to 2 inches. I've scuffed this real quick with a 4/0 piece of steel wool, and I wire brush the inside of these real quick. Let me go put a dab of red permanent Loctite where I need it here, and we'll press these on. Now, it's been about 2 hours or so at the thread locker cure, and this stuff works. The permanent stuff works great. It's 271. It's for threaded fittings, but I actually have it when I did the large dial conversion on this. That's what's holding together this the crossfeed screw. I might show a video on how to make one of these and how I did that, but anyway, that's for another day. So here's what our test bar looks like here. We got our 2 collars on the end, and obviously we're center drilled, and set up to run between centers. It's got to put the lathe dog on this, and what we're going to do is take a skim cut across each of these, here and here. It might be a little bit of run out of these on the shaft itself, because I didn't really 100% dial those in when I cut the holes in them. So we want to make sure that when we cut them, we get a nice clean cut across all of this diameter. And then we can do one of 2 things. We can either run a dial indicator in our carriage around each one and see if there's any difference between them, or we can mic each one, which is what I'm going to do. Before I do that though, I'm going to take the original test bar I made, and I'm going to double check my alignment on centers exactly the way I did in the other video, because my goal is to see if there's any difference between this twin collar test and the method I showed before. The only thing I can think of too is where there might be some deviation, because you are actually taking a cut, unlike you did on the other one, where you only cut the register and use the register on both sides. You're taking a cut across this face and this face, which is where the wear in your bed is going to be. So depending on how much wear you have in your bed, it's going to deviate the diameters. Which my goal was to get this as accurate as possible, which is why I went through and leveled the entire bed first, and then before I did any of this. So I'm going to do this off camera because there's another video of it, and I'm just going to double check my alignment of my centers with my original test bar. See, and then we'll take a cut and see what we come up with. Alright, just went through the alignment process just like my other video. Just before I start, I wanted to get a good shot of the tool I'm going to be using to cut this. So I grab my hand in here, but it's got a nice radius on it. It's cut just like all my other regular tools, and I also have each end of this here is honed to each face and cutting edge is honed on my my stone. So we got a nice sharp bit, and we should be able to be able to get everything going. So let me just put the bar in here on center and we should be all set. Up right where I should be. My tool bit height is on center. I centered it by the headstock center, so I know we're 100% accurate with that. Like I said before, we have this aligned with the method I used before. So what we're going to do is just take a skim cut across each of these without crashing into the lathe dog. Also, whenever you turn this on and you just put one of these on, just make sure that you stand to the side a little bit. In case anything catastrophic happens, this comes flying off to kind of minimize damage to you. So we'll go in, feed in, touch real quick, turn her on. Put some nice cutting fluid on there. I'm only going to take about 5/1000 or so. And we're going to power feed. My power feed is set at, I believe, let me just double check. 1/1000 of travel per revolution. So it's a very slow feed. It's actually one of the finest feeds you can get on a Model B. Alright, now we're getting the full diameter, so we know we'd have minimal run out on this piece, or on these collars. Coming to the end of the cut there. Now, I'm going to disengage my power feed, and without touching the compound at all, feed my carriage over to my next collar. There it is there. And we're going to take a cut on that. And we have full engagement of the diameter, so like I said, minimal run out on that. Coming to the end of our cut. And we're off our cut. Back that out. See what we got for a surface finish. Alright, we got a pretty good finish on each of these. Yeah. I'm happy with that. Okay, so now I'm going to set up where it's best for you to be able to see me use the mic, and we'll see what we got. Now what I have here is just a standard that I had made for my 2-inch micrometer. It's ground on both sides, and it's pretty much 1 inch. This is my Mitutoyo digital, which is calibrated correctly. I just want to show you that this standard is 1 inch, or pretty close to 1 inch. There you go. 0.2 of a thousandth to over 1 inch. So the only micrometer I have that'll be able to fit on these collars is this Lufkin 2-inch. The only thing is, this is only good for thousandths. I don't have a 10,000 scale on here. But what I do want to show you is just at this at this 1 inch standard that I made. At this mic here is calibrated correctly. Alrighty, we're in there, and there you go. I don't know if you can see that. Pretty much right at 0. Okay, so let me unwind this again. Those collars are going to be just shy of an inch. There's 1 inch on mine. There's 1 inch. 1 inch even right there. Okay, let me get the bar. It's my rag. All right. One collar right here. This is going to be the left collar. All right. So right there, we're pretty much dead on 12 thousandths of an inch. Let me see if I can get this to zoom in a little bit without blurring. Yeah, you can see we're definitely dead on 12 thousandths of an inch. Alrighty. Flip it end over end here. Make sure that we're wiped off nice. Now that 12 thousandths of an inch was the one, this one I just did was the headstock end. This is going to be the tailstock end, so any deviation in this is going to tell you. Oh, look at that. We're slightly less than 1/1000th of an inch off on the tailstock alignment, and that's over 12 inches. I'm lying. Let me zoom out here. That's actually over. Say center height. Make sure it's over 6 inches was my goal. My ruler. Right here. That's actually over 8 inches. Over 8 inches, we deviated by a little less than 1/1000th of an inch. I'm pretty happy with that, actually. Considering that the other test bar was a lot easier to make and there was a lot less involved with messing around with it. And that one there can be used for tailstock offset. Deviation of less than 1/1000th of an inch, or a little less than 1/1000th of an inch over 8 inches, man. On a, you know, well, my lathe's actually a 1950, so over 60 some odd year old lathe. Man, I couldn't be happier with that. So it depends on how crazy accurate you want to be. I mean, a lot of this too can be even just tool pressure of either flexing this, or if your center is a little bit tighter on this end, it's going to kind of want to walk it up a little bit more, or even bed wear can give you a different reading on this too. So I mean, it's up to you what method you want to use. But like I said, it was a 1,000th of an inch bigger, or less than a 1,000th of an inch bigger, on the tailstock end than I was on the headstock end. And it is what it is. Alright, just for kicks, I went back over to the lathe real quick and moved my tailstock in towards me about a 1,000th of an inch, just to see if that's actually going to make any bit of difference on this bar here. So just another quick. Let's see if we can zoom in here. Oop, too far. If you can see that. But we're right a hair below the 19 there. Let me flip her end over end. We'll check this other side here. There you go. Look at that. We're right at pretty much the 19 mark right there. Maybe just slightly over. Just about right where we were on the other one. So I'll call that perfect. Now, it's up to you what kind of bar you want to use and how much you want to go for it, but I mean, they both work pretty well. You saw how I made that and how I made this one. You know, I personally, I like this one just because of the ease of making it, and I'm able to use it as a reference for offset and everything else like that. You probably could still do the same thing with this one, but I do like this one a lot better. But it's all up to, you know, how accurate you want to be and how far you want to go in it. But it can be done many different ways.